Understanding XR Controllers and Human Interfaces. Course. Chapter 3. At the successful completion of this day's training, learners will be able to identify and recognize types of VR interactions in games when using controllers. Recognize the limitations and possibilities using the hand tracking features of the Oculus Quest. Create a simple script to show virtual hand presence in the simulation using 3D models and animation. Build a simple teleportation system using CXIA to extend the ready-made scripts provided with Unity's XR. Oculus Touch VR controllers are designed to provide an intuitive and immersive way to interact with virtual environments. First introduced with the Oculus Rift, they have since evolved for use with the Oculus Meta Quest and Rift S headsets. These controllers feature thumbsticks, buttons, triggers, and capacitive sensors that detect finger placement, allowing for natural hand movements and gestures. They use inside-out tracking, meaning the headset's cameras track their position without the need for external sensors. With haptic feedback and ergonomic design, Oculus Touch controllers enhance immersion, making VR experiences feel more realistic and interactive. Let's watch a video where the host reviews the Oculus Touch virtual reality controllers, which bring motion-tracked hand presence to the Oculus Rift VR headset. The video also compares how Touch stacks up against the Vive and PSVR controllers in terms of tracking, features, and ergonomics.
Hey everybody, it's Norm from Tested.
And it's Jeremy from Tested.
And the time has come, Jeremy. Today we're going to be reviewing the Oculus Touch.
It's been a while. It's good that this is here.
Yeah, after 9 months of playing in VR with the Oculus Rift, but using a gamepad or flight sticks, we finally have motion controllers.
That's right. We finally have sort of parity between the three major VR platforms: PSVR, the HTC Vive, and of course the Oculus Rift.
Now, each of those VR headsets has a tracking solution for the headset, has of course a headset, and also some sort of track motion controller system that gives you hand presence or in-game controllers, but each of them does it a little differently. So today we're going to talk about how the Oculus Touch does it, and here they are right here. So sensing, how these things are tracked. Like the Oculus Rift headset, these touch controllers use outside-in tracking. Basically, we have sensors that look at IR LEDs hidden inside these rings here that let the system know exactly what position they are in volumetric space.
Oculus calls it a constellation tracking system. And you've always, in your Rift, you've had IR LEDs within here that blink at different rates. And you can't see them, of course, but these cameras can. And they have them on the back and the front. And that's how it's used to track them. And these will have the same thing.
Now, you say cameras, Jeremy, and that's because the Oculus Touch comes with a second camera.
That's
with
right.
the Oculus Rift, you get one camera. With Touch, you get a second camera. And the setup we have right now is basically your standard setup of having the two cameras in front of you to the side, looking at you. Setting up Oculus Touch, super simple, I found. There is a whole setup process. I think Oculus has done this right, getting the tutorial and the wizard set up to get you acclimated and to make sure your system configuration is done properly. You get your cameras in place, put the headset on, and you draw a boundary system.
Yeah, they call the boundary system Guardian. It's similar in setup to the Vive system, which is they call Chaperone. And you basically want to make a border around your play space. And as you create outlines that connect, the system will fill those in. So the easiest way to do that, you taught me actually, is to draw, is just to paint in your space until you've created, quads that fill in your entire play space.
Right, and this is still 2D space. What you're basically telling the system is what area on the floor you can walk around or move your hands around in. It's not going to take into consideration if you have, lights or C-stands or other things.
That's up to you. When you're setting it up, you don't want to include that in your play space.
Right, but one big difference between the Guardian system on the Oculus setup and the Chaperone system on Steam VR is that with Guardian, you can actually do irregular shapes as in curves and contours to your room as part of the boundary as opposed to just a rectangle.
That's right. So in Chaperone, with the Vive, if I draw irregular shapes, it will basically create a rectangle maybe not a rectangle, but a quad that fits within that space. And that becomes my entire play space. Whereas the space that I draw with the Rift, I then see in VR, if I walk towards the edge of it, it fades in. And I can see that, and it's just as irregular as my drawing was.
Right, and that fade in, you can turn that on or off, or you can have just the outline on the floor. And some games even create their own boundaries based on your play space. So even though you may draw like a big circle or a big irregular shape, Oculus, the software, will determine a rectangle that will be your designated play space, 5 feet by 7 feet, for example, or even like 5 feet by 5 feet. Now, there are 2 cameras. And so the number one question that we are going to get from people is, how good is the tracking? How does it compare? Is there really parity with the other tracking solutions out there, on the high end being the HTC Vive? And I think there are 3 different types of tracking arrangements that Oculus has laid out. There is the most basic one and most games are designed around this, which is front-facing standing.
Yes, that is going to be when you have one sensor set up facing directly forward, and you have the other one 3 to 6 feet away facing the exact same direction so that they're parallel, facing towards you, standing in a position that is maybe a foot or 2 away from your desk area.
That surprised me a little bit, that the software recommends that you make them parallel and not crisscross.
Right, I would have thought they would want to converge on a single point, but I guess they're assuming that parallel gives you a wider tracking volume, and they've decided that that's the way to do it.
You want to imagine cones of field of vision coming out of these cameras, and that's what they can see.
As long as you're far enough away from the 2 cameras, I think that works, because the cones will converge far enough away from you.
Now, there's a little bit of a catch-22 in the placement on the table. Now, I have a very similar standing desk setup at home, and what I found is when I put the cameras in further into the desk, I would get occlusion with the table. And on games where I have to put the controllers down to my waist for holstering, I would lose tracking.
Or Henry or something like that, you actually can sit on the floor, you'd probably lose tracking there too.
Exactly, but if I put the sensors to the edge of the desk, then I would risk being too close to the sensors and then falling outside of the cone field of view. So the best positional setup was actually either putting these sensors at the front of your desk and then playing a few feet away from your desk, or then putting them on tripods and having them a little further back and higher up. So you get that conical field of view.
And you can unscrew the stand. The stand separates about an inch down from the actual camera. You unscrew the base, and then this is a standard tripod screw or mount that you can then thread into a tripod.
Now, this is for standing and front-facing gameplay, and the other 2 types of tracking arrangements are 360 degrees.
They're both experimental, we should say.
And room scale, absolutely. And 360 just means that you're able to stand in your small play space and spin around, which some games encourage you to do.
I mean, there's going to be some games that will require you to. None that I can think of at launch, but Lone Echo was a great game that we played at Oculus Connect, and that's going to be one that requires you to spin around 360. And that's a game that will require one of these 2 experimental modes. Maybe they'll be out of experimental phase by the time that comes. But the way to do experimental standing, you can do with simply 2 cameras. And you put them in opposite corners of your room. Now, it's important to note that one of them will, the one that's sort of on the same plane as your computer, that's going to be fine with the existing cable that comes with the sensor. But for the second camera that's going to go opposite, far away from your computer, you're probably going to need an extension cable for that one.
Yeah, and we tested this with like a $10 5-meter USB 3 extension cable. It worked just fine. Now, having the sensors in the opposite corners of the room, your front-facing, the front of your game is actually going to be diagonally opposite.
Right.
So the sensor is going to be to your left and right.
That gives you the most coverage.
And Oculus recommends having them about 10 feet apart. Now, even at 10 feet apart, this isn't room scale. I'm not walking around.
And Oculus is clear about that. They call this a standing 360 experience.
And even doing a 360 game, spinning around, playing a game like Fantastic Contraption, I didn't notice a lot of occlusion, but there were points where if my back was toward a camera and I was blocking one of the controllers
or
with
outside
one hand,
of its cone,
or outside of the cone, I would lose tracking. And this isn't real parity, because with the HTC Vive, their tracking system has the beacons on opposite corners of the room.
Well, not only that, you get full room scale with
And
only
you
two.
do get full room scale with that. So even with 2 cameras in basically the same places as your Vive lighthouses, you're not going to get as big a tracking volume.
Yeah, and these are all connected to USB jacks on your computer, which means wires running over there, more USB resources, fewer ports available.
Yep. Now to get actual room scale with the Oculus Touch setup, you need a third camera. And this is also, like Jeremy mentioned, experimental. So you have to pay an extra $80, get a third camera. That comes with, I think, a USB extension cable. And the arrangement we've seen is basically having 2 in front of you, as you would for the standing front facing, and then 1 behind you. And that offers the best both 360 experience and then also gives you potentially room scale walking around.
That's right. We did see 2 games, at least 2 games that connect using this setup. I think most people who really like VR, who want that flexibility, they're going to want to sign up for the third camera, the wiring, the having the ports available. It's a bit of a commitment, but that's the kind of experience they're probably going to want.
Yeah, the limitations, I think, with the sensing and the tracking system on the Oculus side are really the conical field of view and the length of the USB cable, and the fact that you actually have to use an additional USB port, just 3 port, for every additional camera. Up to, you can put 4 cameras on this thing. But once you're inside that field of view, precision is totally great.
Oh, I would say it's just every bit as good as the Vive and the Rift has always been.
And range of the field of view of these cameras has been great. Like we did this with our first test with 1 camera. If you're 12 feet away from a camera, as long as you're in that conical field of view, you're going to get really precise tracking with the touch controllers and the headset.
And the room light has a bit of an effect on PSVR performance. That's more of an optical, system, not as high fidelity as the IR system is here. Room lights, we have stage lights on right now, no problem with tracking.
Yeah, so that's tracking, but of course there's also the actual design of the controllers themselves, and it varies greatly between the 3 VR systems.
True.
The most popular one, the one that was the gold standard before Oculus Touch, was this guy. This is the HTC Vive. I call it a wand, but you can call it a controller, whatever you want. But this is a pretty versatile controller. You can hold it in a couple different ways and still get great tracking with it. I can hold it like a sword and play Fruit Ninja. I can hold it like a pistol grip and play Space Pirate Trainer. Or I can hold it like, I like to call it a phaser, more like a pointing remote, and use it like that. Or like games can use it in novel ways.
Yeah, I played a Grand Canyon rowing game where I actually turned it upside down and was rowing with it.
Right. And the Oculus, it's kind of a little bit of a double-edged sword because there's versatility in the ways you can hold it, but because you can hold it in more ways, the game doesn't know as much about how you're holding it, where your actually hands are.
That's right. Developers can't count on that. Whereas with the Oculus Touch controllers, it fits so well contoured into your hand. There's really only one way that you're going to hold this thing. And I mean, not only that, one is made for your left hand and one is made for your right hand. The developers know how this is going to be oriented. So pistols, you shouldn't have to worry too much about getting an odd tilt. All of the virtual devices that this turns into in VR should be in the right orientation.
And I think Oculus designed this for hand presence, to get virtual hands in the virtual space. And in all their tutorials and demos, they really show those glowing blue hands prominently. And a lot of that is benefited by the fact that you have these capacitive sensors in addition to buttons on the controller. So buttons first, you have a trigger button, analog trigger. You have a grip button on the side for your middle finger.
Also analog.
Also analog. And then on top, you have a thumbstick, which works as a button, and 2 buttons, and I guess a menu button, and a spot that works as a capacitive sensor as well. But each of the buttons on top here are capacitive.
Every single thing on the top here, even the analog stick, is a capacitive sensor. So that if I'm in VR and I very lightly touch one of these buttons and the interface, respects this or supports this, my thumb will touch that. And if I let go, the thumb will go up. So this doesn't necessarily sense where my fingers are in 3D space, but it does allow me to do simple gestures like pointing. If I take my finger off of the analog stick, it will point forward. If I lift my thumb up, I'll give a thumbs up. So I think for social, this could actually be pretty great.
Absolutely. There is no capacitive sensor on the grip button, so you can squeeze it, and in some games, in some situations, it'll make a fist, but you can't, for example, do a high five while holding the Oculus Touch controller.
Right. Yeah, it's interesting. This is the first controller that I have ever really wanted to wear this strap on.
That's right.
Because with the Wiimote and with the Vive, I feel pretty confident I'm not going to throw or drop the thing, although famously, a lot of people have. This, I don't know if it's because my hands are in a grip formation and I'm constantly throwing things in various games. I feel like there's a strong chance that I actually will throw this straight into my TV. So I feel much more comfortable wearing the wrist straps with these.
I think there's two reasons for that. I think one, because even though you're holding it, I'm never really gripping it that hard. It almost rests on my fingers as opposed to having to hold it and grip it like some type of stick. And two, because of the strong sense of hand presence, you don't see the touch controller in a lot of the experiences. I forget that it's there. I just think that I'm pointing and making fists and giving thumbs up. And so, I have the wrist strap on just in case it falls off my hand. I'm holding it pretty loosely. It's a very lightweight controller. I also like the ability to let go of the controller, go to my keyboard, type, and then flip the controller back up and have it in my hand.
I think the fact that I feel like I might throw it is testament to the immersion level that this provides.
Yeah, and of course it could be a little better. I would love for it to actually stay in place and I'm not gripping it at all, but maybe that's for the future, as we've seen with some of those prototypes on the HTC Vive side. You did mention that they are asymmetrical, which is an important thing. With the Vive controllers, you could just pick up any of them and not have any problem.
And then whichever one you had in your left hand would adopt the left hand functionality. With these, you actually have to pick up the left-handed one and put the right-handed in the other one. And the only problem that I've run into that is that if I have the headset on already, I can't tell. I've been spending a few days with these. I still can't tell just by looking at them which is left and which is right immediately. So I'll reach out with my headset on, I'll see them in VR, and then I'll have the wrong ones, and I'll try to fumble to get them flipped around. That's the only issue. I wouldn't say that it's a deal breaker. It's just something to consider. Maybe take a really good look, learn how to discern which is left and right, maybe store them on your desk in a way that's easy to pick up. You'll know which is left and which is right.
Yeah, and there is no real elegant way to store it on your desk. If you have it like this, which is what I want to store it as, it just kind of rolls over.
Yeah.
So I put them face down, which then makes it easy to grab like that. And like I said, they're pretty lightweight. We have medium-sized hands and they nest really comfortably in our hands. We put it in the hands of people with larger hands and smaller hands, and it was still contoured to fit their hands pretty well. There's also a battery in here.
It's interesting. It's the only VR device that actually requires you to replace the batteries, ever.
That's right.
Everything else is rechargeable.
Right, and so it comes with AA batteries, one AA battery for each. They've lasted for a long time. We've been playing it all week, and we're still 3 bars out of 3 bars in the UI when we check the battery. And you can easily replace the battery by removing the cover, and then there's a nice magnetic seal for that to snap that back in place.
I think you're probably going to want to invest in a couple of rechargeable AA batteries, though, just for the sake of not having to buy new batteries every week that you actually use this thing.
So that's the hardware with Oculus Touch, but there is a large launch lineup of games. Content's the most important thing.
True that. Thank you, Oculus, for giving us a ton of bundles with this thing. I mean, we get at least 3 games at launch for free.
Yep.
You get Dead and Buried, you get
VR Sports,
and Medium.
You get Medium, Quill,
and also The Unspoken.
The Unspoken. And then in the future, they also announced Robo Recall.
Coming next year.
Will be free as well. But I want to split content into basically 3 categories as well. Okay. There's cross-platform content. Developers who have been working in VR on the other platforms with motion controllers for the past year and now have ported their content over to Oculus Touch. How does that play?
What's amazing is that a lot of that is already on Steam, and it just works. I played Space Pirate Trainer and Job Simulator on Steam, and the game seemed to think that I had a Vive controller, but everything worked flawlessly. I was very impressed with that. So when I loaded up Space Pirate Trainer, I believe that was it, when I got into there, you can see a Vive controller where your touch is. So it's very interesting. It's almost like you now have a Vive, because in VR you apparently do. But the way that the analog works between the 2 devices was, I think, genius. So completely different interfaces. The touch has the same number of buttons, but it has an analog stick instead of a touchpad. And the way that this works is when I'm in the game, I see in VR the Vive controller. If I move the analog stick around, I see a little phantom dot move around on the touch controller. And if I press the stick, then that's pressing the actual touch controller. And these two buttons are mapped to the two
Right, the
buttons
top
right
and
there.
down menu and home buttons are mapped to your two buttons.
That's
Because
right.
there's technically more buttons on the touch controller than there are
That's
on
right.
the HTC Vive controller.
Plus the capacitive aspect. But they really needed that capacitive aspect too, because when I just touch the analog stick, that's when the little dot shows up. It has nothing to do with moving it. Very smart.
Right, and then I also played a bunch of games that exist on other VR platforms in the Oculus Store, because those developers have ported them over. So playing a game like Space Pirate Trainer works perfectly well in Oculus Home. And what I found is, initially I was a little less accurate using the touch controllers, and maybe it's the way I'm holding the controller is a little different than the way I would typically hold the Vive controller, even though the angle where you grip it is essentially the same. And then there are games like Fantastic Contraption and Job Simulator, which are really designed for room scale. And on the Oculus Home platform, both those games have modes to play them standing and front-facing forward.
Okay, but is that mode any different than the smallest scale version on the Vive platform?
No, it's exactly what they've already put into the Vive platform. Because obviously some people who have Vives will only play standing front-facing only. And then the third type of content is Oculus exclusive content, things that they've made to really take advantage of the design and tracking of the touch controllers. There's The Unspoken, and you played some of that in multiplayer.
I think it's fantastic. Yeah, unfortunately, there's not enough out there for there to be multiplayer access all the time. But they did have an event last week, and I was able to jump in there and play a couple matches. I won 2, I lost 1. I think that is the standout finesse game. It has the most subtlety in terms of the amount of skill required to play. That's going to be one that ramps up and you want to go back to. It's great. I mean, we've talked about it before. It's a magic game where you're basically one-on-one and you're casting spells and you're putting up shields and you're using resources to cast larger scale spells. It's a lot of fun. It's the learning curve is probably the steepest of all the games that are out there. The other one is VR Sports.
Both those games take advantage of gestures and hand presence to some extent.
Sure.
The idea that you're not holding any type of controller in the virtual world, you're just moving your hands around, whether dribbling a basketball or putting your hand up to cast a shield or throw a fireball.
That's right. Yeah. So the object that becomes your controller is a hand, and this controller lends itself very well to that.
Yeah. I did also play Robo Recall and Dead and Buried, games that have you hold pistols. And I think Dead and Buried did a fantastic job of it. It's one of those things where if you're wearing the headset and you see the virtual gun in the headset while peeking out and seeing the grip, how you're holding the controller in the real world, it's perfectly lined up. Obviously, it's a first-party game. They designed that perfectly, but the guns felt super, super natural.
I agree. The angle that they got those pistols at works really well.
Yeah, I think they spent a lot of time working on exactly what that angle, what that contour would be.
That's a heavily multiplayer game, so that's another game, unfortunately, we haven't had a ton of chance to play with other people yet. But I'm looking forward to that. That's a game that has voice support built into it, I believe, and that just comes right out of the headset. I think that'll be a lot of fun.
And then there are a bunch of non-game exclusive content that Oculus has made, including Toy Box, Medium, and Quill. Now, Toy Box, I know a lot of people were excited about it. It ended up being more just of a tech demo.
Yeah, I mean, I think that the Toy Box I was hoping would be something even akin to the Lab from Valve, but it really is 3 different rooms where you can jump in, you can throw some shapes around, light off some fireworks, control a little radio-controlled tank. Not something you're going to be going to very often, but I could understand if it was helpful for them to develop and test out with.
It seemed to be a thing they made to give 15 to 20 minute demos for people new to Oculus Touch, like they did at E3 2 years ago when we first got hands-on with the Touch.
One thing we didn't mention about the setup process is the cool 1980s robot scene that you actually use when you're setting them up for the first time. It gives you a chance to explore and interact with objects. And it's almost like an evolved version of the Toy Box. I think that they did a good job with that.
Yeah, but the actual content creation tools, Medium and Quill, I think are fantastic. Now,
absolutely.
On the Vive side, we had Tilt Brush, which was painting in a virtual space. And the equivalent, the analog for Tilt Brush on Touch isn't Medium, it's Quill.
Right.
And Quill is just, it's like Photoshop in VR.
Well, yeah, you might also be saying that because the interface is very technical. It looks like an old school Photoshop interface. There's nothing cutesy or VR or anything about it. It's even to that extent, they're probably going to expand it and prettify it a little bit. But it is very, very powerful, and it's really well done. As you draw within that space, the sounds that they even incorporated into that app make me feel so immersed into that space, and I was highly, highly impressed by it. The drawings that you can load in that other people have done with it,
oh my goodness,
they really show off what's capable. And they've got all the features that Tilt Brush has added over time, such as scaling and moving the world around. And it's highly, highly impressive. I look forward to seeing more of the professional work done in that app.
And exploring those other drawings, I found myself less walking around and more scaling the drawings around me and pulling them toward me. There's one particular demo where it's a drawing of two aliens in a car. One's holding like a snow globe, and as you expand and blow up their world, you can go inside the snow globe and you see another scene in there, and you go inside another scene and deeper, and it just plays with the idea of scale so well. Whereas I believe on Tilt Brush, initially, it was more about just that room, walking around the room, the canvas being your one-to-one room.
What sets Quill apart from Medium is this idea of volumetric drawing. So Quill, you're still drawing like Tilt Brush in 2 dimensions, everything. Well, you're drawing in 3 dimensions, but the thing that goes into space is 2-dimensional. It's basically paint. But in Medium, you're sculpting in 3D, you're basically sculpting 3D objects with blobs, and you expand things and stretch things and cut into things. And that's more akin to sculpting. And it's really cool that they're doing that, because like we don't have anything like that on the Vive yet.
And my concern with those tools is, would they be novel tools, or would they actually be robust tools that professionals can use? And it seems like for both Quill and Medium, there are export abilities and lots of nitty-gritty tools that I would not know how to use, but professionals could take advantage of. I've been following a lot of sculptors who have been using Oculus Touch, and they've been putting out some amazing work, and we're going to hopefully showcase some of that on the site as well.
It's super cool. Yeah, you can export cube maps so that people can share. You can share these things, export animations. I think you can even export models, so you can bring them into 3D modeling platforms. It's super cool. It seems like a whole new realm for artists to experiment with.
Obviously, since Touch has come out, I've played so little of pure gamepad games on the Rift. And speaking of gamepad, there is some type of gamepad parity with the touch controllers.
Yeah, that's right. I mean, the touch controllers, if you look at them, you got a couple analog sticks, you got 4 buttons, so it kind of maps. And Oculus has part of their SDK. There's this compatibility aspect to it, so that I loaded up Lucky's Tale with the touch controllers just to see how it works. And I moved around with the left stick, and I jumped with the right stick. But so on the right stick, I have A and B, and on my left hand, I have X and Y, just like an Xbox gamepad if you put them right next to each other. But there is a problem, because sometimes you want to hit X and Y while running, and I'm using the left analog stick to run. I can't hit those buttons while I'm running.
With your right hand?
With my left hand.
With left hand, yeah.
Yeah, and so, I mean, I can understand why that is, because they're emulating an Xbox gamepad, but there's going to be some games that were made for gamepad, and even though that the compatibility exists on the touch, you're still going to want to use a gamepad.
Yeah, and there is no way to attach tracking to those gamepads. The Oculus Touch actually comes with this clamp that lets you connect the touch controllers to the guitar or the Rock Band accessory, but there's no way to attach this to a gamepad, so you would have gamepads tracked like PSVR, having the DualShock controller tracked in-game.
I mean, that's an interesting idea. I wouldn't be surprised if eventually we get some sort of tracked gamepad. I mean, that's one thing that the PSVR has against everyone else, is their gamepad is tracked in virtual reality.
Yeah. So we talked about the content, we talked about the hardware, but really, as a purchasing decision, Oculus Touch is a no-brainer for anyone who has an Oculus Rift.
No, in a sense, I mean, this is something that we've been saying all year long. I mean, we've been saying we can't wait for Touch to be out so that we have this kind of parity. Anyone who bought an Oculus Rift, the gamepad games are great. And I mean, I think Oculus has had a lot of success with that this year. But if you haven't tried this yet, this is just a whole new level of immersion that people on Vive and even to some extent PSVR has been experiencing this year.
So the real purchasing decision really is, if you're a current Oculus owner, is whether to buy the third camera or not. And while the third camera is going to improve your tracking, field of view, and give you potential experimental room scale tracking. I think right now you don't need it for the vast majority of content out in the Oculus Store.
No, I would absolutely agree with that. Just be prepared to be in a standing position facing forward. Even Robo Recall, which is a game that's not even coming out until next year, which will be free, it allows you to control which direction you're going to face once you teleport. So they're already working in ways around this limitation.
And then for people who haven't adopted either the Vive or PSVR or the Oculus Rift, what should we recommend? I mean, I think as an owner of all three systems, since having touch, the one I'm gravitating most toward is touch.
Well, me too. The touch controllers are great. I would probably say that they're superior to the Vive controller. The headset, I've said, is superior already.
In terms of comfort.
It's lighter. The headphone aspect is just, it's hard to explain how much nicer that is just to have headphones built into it. The one downside is you need USB resources. You need the cables all running to your computer. You need more than 2 sensors if you want to do room scale. So this is the downside. Like I do not like this aspect more than the Vive, lighthouses. I think those are superior. But the takeaway experience, yes, on balance, I would say the Rift is a stronger one.
And if you look at the spectrum of VR content available right now, yes, the Vive came out with track controllers almost a year ahead of Oculus Touch, but there haven't been this whole library of room scale dedicated games that require perfect room scale that would compel me to buy the Vive over this. If you look at the Steam VR library, you can play the vast majority of those VR games with Oculus Touch just as well.
The wall that people ran into very quickly with room scale was the limitations of even the widest room scale. People want to walk beyond those walls, and so we ended up with teleporting games anyway, which you can play standing in one spot. So you have a few handful of games like Job Simulator that really do take advantage of a large volume. Those are very small. And I think the number of people who are going to be capable of playing those is going to remain a small percentage of this genre of gaming, that it's not going to be an incentive. There's no real incentive for developers to develop for those kind of spaces. So
yeah. So that's the Oculus Touch. It is out now, December 6th, and we'll be playing more of these games and telling you more about them on our site. Thank you, Jeremy, for testing and reviewing them with me, and we'll see you next time. Bye.
The hand tracking algorithm in the Oculus Quest leaves a lot to be desired, but it also shows the potential of hand tracking for different types of apps and game interactions. The Hand Physics Lab app for Oculus Quest 2 is still in alpha, an experimental app that gives you an idea of what can be achieved. Let's watch a video discussing hand tracking features in VR.
Hey everybody, it's Norm from Tested.
And it's Jeremy from Tested.
Welcome to the end of Oculus Connect 6, day 2.
We hardly knew you.
I know, we had to do another episode of projections because on this day we actually got to use hand tracking as well as go back and do it more with Oculus Link, chat with some more people, play some more games. But let's kick off with our hand tracking demo because we learned a lot.
Yes, we did. So we were able to go into what they are calling Elixir. Now this is, I didn't know if this would be a tech demo. This is apparently a game that everybody will be able to play one day. This will be out on the Quest store whenever hand tracking launches next year. And in this game you're basically in a cauldron you're not in a cauldron, you're surrounded by cauldrons and various witches things and wizard things, and you can walk around and reach your hand out and engage with the environment. The first thing you do is put your hand down on a platform and it changes the color of your hand. Now just from a starting point, I had a funny experience because the first thing they tell you to do is walk forward, and I'm thinking, well, I mean, I don't have my controllers. How am I supposed to walk forward? And obviously, like, this is the stupidest thing ever. I've been doing VR for like 5 years. I should know I'm supposed to physically walk forward.
I had a very similar thing because at these conventions, they give you demos and someone puts a headset on you and they tell you to stick your hand out so they can put the wrist straps around you for the touch controllers.
And so you're waiting like
a robot. I instinctively put my hands out for the touch controllers, but of course, you don't have to because it recognizes your hand.
Right.
Now, the way they're doing this is also interesting. We learned a bunch about the technology for the hand tracking. It's not using, IR sensors. It's using computer vision, detecting the edges of your hand and doing a skeletal model. They say each hand will have about 25 points of articulation. So 25 points so you can have multiple different poses.
For the skeletal modeling.
For the skeletal modeling of that hand, which isn't like a technical limit. It's not like this is the most points.
It's enough.
Just based on the actual skeleton of your hand
Right.
is enough to get all those different poses.
Now, I had to be cued by the director in order to actually start playing that Witches game, because all I wanted to do was play with the tech and
Yes.
see if I could break it.
yeah,
And-
we want to break it immediately.
And I gotta tell you, like, this is early still, but it is easily breakable. Like, the occlusion is much more real for the hand tracking than it is for touch controllers.
Yes.
And they just haven't gotten to the point yet where they're able to do that predictive modeling of where is it going if they don't see it. I'm sure that that's coming, but currently, if you hold your hand out like this, I should say with a single hand, this type of occlusion works very well.
Yeah.
Like, I didn't see any errors there whatsoever. It can't see these fingers, but it does interpret where they should be. If I put another hand behind this hand according to where these cameras are, it loses this hand entirely. This will fade out.
And that fade out I think, is a really smart thing they're doing. I think at every frame, they have a confidence level for how well they think their system is modeling your hand. And so, like you said, when you are blocking your own fingers, the skeletal models still, they're pretty confident they know where the fingers are, so it won't break the system.
Right.
And then if you block, or if you do things like I tried smacking my hands together, tried interlacing the fingers.
I was told that's coming.
That is right.
I was told that that is on its way, that is something that they can definitely solve.
Yes, but if they're not confident, then it fades it away. It won't kind of like throw the skeletal model in all sorts of places. Another interesting thing they do is they have a hidden calibration technique. At least in this game demo, in the Elixir, where you said the
Right.
first thing you do is you put your hand over these stones right in front of you. Well, what it's actually doing while you're doing that is it's calibrating, because that's the sweet spot for where the lenses see the stereo overlap, right? Because everyone's hands are really different, right?
Right.
Different sizes, different shapes, different colors. And so when you have this overlap between the two stereo lenses in the front, right in that middle sweet spot, putting your hands out there, they're going to then make sure it maps
That's
to your
the perfect
hand.
position for them to be able to detect depth.
Yes.
How far your hands are away from your eyes, and so that when you move them out here, they can do better interpretation of where they are in Z space.
Right. So even if you have one hand off to the side and you see it within the field of view, it's still going to be there, even though it's outside that sweet spot for depth mapping, for stereo overlap.
Right.
Because they can still tell based on how physically big it is.
Right.
Like your hand is still there.
I was actually very impressed by the tracking volume, because I expected, like, touch controllers I get because they have the LEDs all around them. They go beyond the visible cone of vision, the field of view, so that you can move your controllers and you never see them stop, right? Like, you can lose the tracking volume back here, but you don't see that. Same thing with hand tracking. I expected it to be narrower. I would have perfectly forgiven them if the hand tracking kind of ended out here, but no, it's the same thing. You move your hands if they're out of your field of vision. It does lose tracking out there, obviously, but you don't see that. They do a perfect model of it all the way across the full field of view.
And of course, once you have the hands in the virtual world, there's a whole different paradigm of interaction models. There are no more are there buttons, right? So there aren't any, at least in this demo, virtual objects that you're picking up, because you don't get the haptic feedback. So we chatted with the engineers and designers and talked about the solutions that they've come up with, and they talk about passive haptics.
Haptics.
Passive haptics include what your actual hands itself. So they have one gesture that they're kind of building in, which is like the click is the pinch gesture, because you are feeling your own fingers. You have passive haptics there.
It seems like developers may have access to that as an event, like as a pinch event.
But they also know where your arm is. So theoretically in the future, you could have passive haptics by tapping your
that
wrist.
Is not at launch.
Not
just
at launch,
to be clear.
but things that they're thinking about.
Yes, he said you're on the right track. And that's absolutely true. I would love for that to be the case more and more, because the whole problem with touch, and hand tracking is great, but people are so used to using controllers that I think they're going to take for granted the fact that you don't actually get any haptic feedback, even passive haptic feedback from a button press. I'm not talking about rumbling. I'm just talking about the act of pressing a button that has an end to the throw. That's something we take for granted. We've taken for granted since the Atari. We don't have that with hand tracking. And people are just instinctively going to want to put buttons in the air and make things that you can engage with and grab. And that's not going to feel right. So I think developers are going to go through a whole new learning phase about what works and what doesn't with hand tracking.
One thing I also noticed is that I felt like I was jumping back to 4 years ago and using something like touch for the first time, hand presence for the first time, where I had almost unrealistic expectations of interaction, what I could do. There's a virtual character in this Elixir demo, like a character, and all I wanted to do was pet its head and rub its belly, because my hands were there and I was getting I was seeing my fingers there, more of a hand presence than I would get with touch controllers. And so
Vastly.
my expectation was that I would be able to interact more with those objects.
Yes.
But that wasn't built in, so developers will have to reconcile that as well as they're designing these interaction models.
Right. I think that there is definitely, like you said, a higher degree of presence, of hand presence, because your fingers are modeled and you see them move when you move. And it's going to be wonderful for people who maybe they're not in it for the games. They're in it for some productivity reason in the future, where we're doing more productivity in VR, or for training exercises. If you're learning how to use a console and there happen to be big buttons on it, there is, and one of the demos that they showed is basically a training exercise for somebody who's looking for water damage in the house. And that's like a good example of something very simple, where you're going around and you're pressing, you're pointing at things.
As opposed to in traditional VR, grabbing a handle and opening a cabinet,
exactly.
It's just tap to open because you can't grab to open right now.
It's very user friendly. It's very newbie friendly.
Yeah, and intuitive as well.
And you know what? This is a good point to point out that when your hand disappears, there's an element of it still tracks. Like, I was surprised by how quickly it could reacquire my hands once it lost tracking. In that demo where you're pressing the buttons to open the cabinets and close them, I was losing due to occlusion, and I was still able to do those things. I was still able to press even though my hand had vanished. So it's clearly reacquiring before they're re-implementing the graphics.
And we did our whole gamut of tests. We tried to do the Vulcan salute. We tried to do single finger salute and all that stuff. And most of that stuff did work.
Hey, like this stuff, it's solid. Very, very impressive.
And now also interestingly is that they may be thinking of this for UI, for maybe the home, right? Not just in-app experiences. They showed a couple seconds of what it would look like in the shell, in the home environment. And right now we have laser pointers with Oculus Touch. We're very comfortable holding that up, laser pointer. How do you do a laser pointer, right, in hand tracking? Well, they have an example where they then take your arm and they project a beam essentially from your arm, so wherever you're kind of pointing, no matter how your wrist is bent, that's where the laser point would be, and then you do the pinch to click.
Really?
And then a long pinch would be a long click or something.
I'm sure developers are going to try 1,000 things, and they'll land on the right one.
But also,
you could do a gun thing if you wanted to.
It changes your relationship with how far objects are away. When we have laser pointers, like we do with touch controllers, you don't necessarily need to go up to things and grab things. You're kind of pointing and pulling things over and pointing. If you don't have that ability and you're forced to go up, then it is making more use of space and positional tracking.
Although, like we were saying before, when it comes to hand tracking, because you lack the haptic feedback of actually feeling objects, doing things virtually from a distance might actually be the better solution in terms of not breaking the illusion. Like I think levitating things like force powers, or like I said before, the Doctor Strange kind of thing, where you're mystical and you're not physically touching anything, you're making things happen. I think that kind of thing is going to lend itself well to VR.
There's like
interface.
A near infinite number of poses you could do with 25 track points per hand.
None of which that run out of battery too.
And that's the other thing. They're really proud of the fact that they could use the extra DSP overhead and just a little bit of the CPU to calculate the hand tracking.
They're saying it's going to cost 8 minutes of a full charge?
Yeah, exactly. If you use hand tracking as opposed to touch controllers and you ran a side-by-side in their test, you would lose about 7 to 8 minutes of battery life, which they're really, really proud of. Now, currently with that implementation, they're also tracking at 30 FPS, and so we did see latency as I moved my hands fast left and right. It was a little bit of
I think Carmack
drifting.
maybe an 80 millisecond delay too, but they're going to whittle that down.
That's the hope, before it comes out next year. And this is, it's not replacing touch. I think they made it very clear it's going to complement that. Haptics on a physical controller are still going to be very important, but it is essentially a free upgrade for the Quest users and potentially, hopefully, for Rift users.
I mean, it's another option. It's in the toy or tool in the toolbox for developers to use. It'd be interesting to see how many games actually incorporate it, because I really think you need to make a game from scratch that is for hand tracking. I don't think you're going to see too many games that offer you touch control or hand control, because that's going to be really difficult to solve.
Yeah. This whole hand tracking demo was in what they call the innovation area, where they're running a bunch of experiments, including the virtual spaces, the Horizon demo, and also they had a mixed reality demo that was really cool.
Yeah, this was definitely cool. It did remind me of last year's Dead and Buried experiment, where there was basically a 4v4, I want to say, multiplayer.
Arena scale.
Right, arena scale Dead and Buried. Basically something that you might see on location, but it's entirely in Quest. In that demo last year, there was somebody walking around with an iPad who could actually see into the game world. And
Right.
they could see the players, and the iPad itself was positional tracked in that same space that the players were seeing. What that couldn't do was actually incorporate the real world. It was simply a portal into the virtual world. What they've done now is they've basically done mixed reality filming purely done in software. So there's no green screen. There's no added, layering done, compositing done by the game engine. It's just like the iPad is now tracked as it was in, positional space, but now it sees a person, it recognizes that person, and it maps them into the correct, position in
Yep.
Z-space, and then surrounds them with the game world.
It does the clipping as
Right.
well, all in real time.
Now it's rough. I mean that clipping, that masking that it does is definitely computer
Yes.
estimations all over the place.
Yeah.
But it's good enough. I mean, it looks really cool.
And it's doing that with one camera on the iPad as
Right.
well, getting that data, getting the IMU data, sending it back to the headset, and then aligning.
The mapping, the aligning is spot on. You see a person holding weapons in Dead and Buried. Now, what's interesting was they told us that rendering is being projected from the headset onto the iPad.
Yes.
So the headset is actually rendering both perspectives.
2 views, in fact, probably 3 perspectives, because you got left eye, right eye, and also wherever the camera
Yeah.
is. So probably not a very poly-intensive, graphically intensive
Exactly.
instance of that Dead and Buried
That's not
environment.
something every game's going to be able to incorporate. A lot of games struggle just to incorporate casting,
Yeah,
which is
right.
a duplication of one of those perspectives.
But we totally see this as the future of casting, getting people who are not in VR to understand what people in VR are not only seeing, but
Yeah.
what they're doing.
Right.
And they can do that in a seamless way with something that a lot of people have. It's like a tablet.
Could you imagine? I mean, if
would
I'm
love to.
playing in VR and you just want to see what I'm doing, even if it didn't do that amazing, compositing, if it just showed you the game world and maybe my avatar in it, by holding your phone up to my space,
Yes.
I mean, that would be a killer feature for the Oculus app.
No promises as to whether that mixed reality experiment's going to be a shippable product or going to be accessible to developers, but we'd love to see that as something that eventually comes. I think VR needs it. We did get a chance to get into the weeds of the technology of all this stuff with a conversation with Sean Liu. So we're going to leave you with that, but thank you for watching our coverage. We know we had a lot of VR and AR talk this week, a lot of episodes of projections, and we'll have more impressions of game demos in the future from other demos we did here, but stay tuned for a chat with Sean Liu. All right, so we are so thrilled. We've been looking forward to this conversation for a long time. Sean Liu is here. Sean, product manager at Oculus. You're the guy we go to ask the technical questions.
Let's see if I have some answers.
Well, there were a lot of announcements at this event, yesterday's keynote. Of course, on the Quest side, we saw there's Link announced, there's a Horizon, of course, hand tracking. We've used Link, we did the Horizon demo, but we had a lot of questions about all this stuff.
Yeah.
So let's start off with Link, I guess.
Yeah.
How does this compression work? And what are the trade-offs that you as an engineering team had to make to get this to run at low latency, to choose resolution and performance?
It's pretty crazy because we wanted to really enable as much of the Rift experience as possible on Quest. But here you have a device that's really designed for standalone. It has a different refresh rate, it only goes to 72 hertz, whereas Rift S goes to 80 hertz. And you want things to just look good and feel really good. So there's a number of considerations here. The first really is around resolution, like how much can you get into the system. And we actually just use essentially a video pipeline. If you think about it like live streaming a video, you're taking what comes out on the Rift side, on the PC side, you compress that down, and then you decode that on the Quest side and you replay that. The next consideration that really becomes latency. Now you've got a cable, it's dedicated hardware here, so that really cuts down on a lot of that latency. But you still do get a little bit of issues, and you'll actually notice this if you sort of look side to side or move your controllers really rapidly. You'll see a little minor artifacts, and those are things that we'll need probably dedicated hardware on the actual device itself in the long-term future to really get away. But on the Quest side right now, it's it's getting really as close as possible, and we're really proud of how far it's come.
When you talk about those artifacts, that's not video encoding artifacts. Those are time warping artifacts, or what kind of artifacts are you talking about?
It is sort of that whole pipeline process of doing the encoding, the decoding, and in that time there, now you do have a little bit of time warp that also happens on both sides.
Right.
So you get that whole system isn't originally designed for plugging that all the way through. And because of that, you notice these sort of small artifacts there.
Was Link always in the picture and it just wasn't ready at launch? How long have you known this was going to happen?
It actually has been an internal discussion for some time. I think John Carmack talked a little bit about in his keynote, where internally there was sort of a question about, could we do this? What's the quality of it going to look like? The original, design of the system wasn't designed around this as an initial sort of a core tenet. It was meant to be standalone, a different class of content, really reducing friction. But there's always this little hope on could you use the video encoding and decoding pipeline, and what could you achieve with that? And so it's pretty remarkable what the team has done there.
So it's existing pipeline. It's using, of course, all the benefits of the architecture of the SoC you're working with, and that's where John Carmack talks about having the cap bit rate at 150 megabits.
That's right.
That's how you make those trade-offs for resolution and frame rate.
Exactly. And the question was would it be good enough? And I think after trying on the show floor, hopefully, people will have a really good impression and be able to see for themselves if they think it's good.
So tell me about the cable. I understand it's 5 meters long?
It's 5 meters long, yeah.
Okay, and is it fiber optic inside?
It is. Now, you really can use any sort of cable you'd want that's USB-C. You can even connect on the other side to USB-A. The trick here is actually just a number of considerations. So the first one is that Rift content on Rift S, it's a 5 meter cable. So we want people to have the same sort of movement of freedom because content developers are designing around that length. The second big issue really is the bandwidth on the cable itself. So if you are USB 3, Gen 1 compliant, you're going to be fine. Not all cables sometimes will hit that spec.
But you can't be 5 meters and be compliant with that.
So this is why we've done a custom cable, just to make sure that the actual specs of what you see in the throughput are going to be good enough. And that was really it's difficult to find a 5 meter cable in market that really satisfies those constraints. And we also think a lot about the charging side. So power is a really big issue. And if you're using USB-A to USB-C, you don't get all that charging. So we want to just create an option where if your laptop or your PC supports USB-C, you can actually get that charging through onto the device. And so those are some of the considerations that led to a custom cable. We're not if you have solutions that work for you, or developers, you don't need that length of a cable, you should definitely use off-the-shelf ones. That'll be a lot cheaper and easier.
And it sounds like the implementation will be, when you plug it in, it'll be basically a Rift experience. You see Dash, you see Home, you can do the other sources like Steam. That will all work out of the box.
That's right. We wanted to really mirror the Rift platform and experience as it exists today. No differences. We wanted to unlock as much of it as possible. We've heard from a lot of the community that hey, I have a Quest device. I think you guys even asked before, could this in theory run Rift content, through that USB port? And so this is trying to deliver on that ask to the community.
Expands the user base potentially dramatically for those PC titles. Did you ever consider the wireless approach? Carmack mentioned things like dedicated dongles with special firmware. Why not wireless now? What do you see as the kind of limitations?
Yeah, we wanted to start with a tethered approach just because we knew that this is the highest likelihood of us delivering on a really quality experience. So we're just starting with that first, but we've got exciting things in the works.
It sounds like you can incorporate time warp in a way using the wired approach, or at least maybe even just being first party in a way that third parties can't. So once you eventually even get to wireless, you'll have that advantage too.
That's right. It's being able to have both the PC side and the standalone side, and then customizing the stacks on both fronts to really make this work, I think is how some of that magic happens.
It also sounds like you're taking over completely, you're only doing decoding on the headset, right? And of course tracking, but you're not doing GPU rendering. And does it make any sense to do both remote rendering in combination with local rendering, or what are the problems with that?
It's actually a really nice optimization if you think about like, okay, could we get rid of, say, controller latency and jitter by doing that entirely on the headset and then rendering a lot of the graphics side on the PC?
Yeah.
The trick here is that you make the developer story really complex and really complicated, where now as a developer you have to fragment how you actually design your system and do something specifically for the remote rendering pipeline that's different than how you develop the content otherwise. That's a really costly and expensive and complex trade-off for developers, so we decided not to go down that approach just for the sake of the development side.
Something that was also surprising to me, and maybe unrelated to Link specifically, is that John Carmack talked about the OLED panel on Quest theoretically could push to 90 hertz. Of course, it would void your FCC certification. Now, is that something that was also tested through Link as well, rendering at 90 and pushing it over?
We really kept just to the Quest current specs on the 72 hertz side. There's also a lot of other trade-offs you get with the power side, for instance, and so looking at that holistically as a system, we're like, let's actually just keep to the Quest hardware specs for now, and then just render the content through. But we'll explore it as we get feedback from the community on what things we should tweak or improve on or change.
I want to talk about hand tracking. Is that good?
Yeah, let's go to hand
Hand
tracking.
tracking.
All right.
Yeah, let's talk about it.
This was the big unexpected to me, and this was a surprise. So the fact that you are accomplishing hand tracking at all, given everything the headset's already doing with world mapping and controller tracking, however, I did learn today, I think that currently you can't do hand tracking and controller tracking simultaneously. Is that right?
That's right.
Okay, but the hand tracking is fully articulated, 10 digits of my fingers, you're handling occlusion in some respects. How long has that been in development? Has that always been a known?
This has been, a pretty big investment from the organization. Actually, it's through Facebook Reality Labs has been working on hand tracking for quite some time. You guys might remember some of the old, I think we did like a blog post on this with a lot of the tracked hands with like gloves.
Gloves, yes. There's a photo of Mark Zuckerberg with doing this.
Yes.
Yeah.
All of that work is actually foundational in tying into this whole system. Today, actually, we use a lot of those systems for just ground truth tracking. You're not going to get better than having actual fiducials on your hand for tracking than, say, we're using just the Quest black and white cameras there. So you're not going to get like a higher fidelity and resolution than that system. What you can do is actually do combinations where you can do training data, ground truth data using the more robust systems, and then use that to really train and hone your systems using the Quest tracking cameras.
Carmack mentioned an 80 millisecond latency with hand tracking versus controller tracking, touch tracking, which is much lower. Is that something that you'll be able to reduce?
Yeah, you also have a chance to try the demo and see for yourself on how that latency feels. There is some latency, but this is like a continuous work in progress. We think that there's still room for improvement. So between now and next year, when we do the SDK launch, I think we'll have a lot of improvements.
And that latency is a factor of the frame rate you're capturing with the cameras?
It's a combination, really thinking about the whole pipeline of the system. So you're using the inside-out tracking cameras to really just taking those raw frames, and there's really multiple steps here. First, you're trying to just identify where your hands are and sort of do a bounding box. Then you're trying to map out actual features to say, okay, here's roughly where we think key features of the hands are, and you can almost see this like it looks almost like a little skeletal with big dots and lines. And then we're going to map the actual model of the hand on top of that and sort of fit it to that. And so that whole pipeline of getting through there does add some latency, but we'll make improvements.
So I know you can't, as we said, use controllers and hand tracking simultaneously. I know you can't track the controller, but can I use the gyro, the buttons, the analog stick in one hand and have my other hand tracked?
For now, at the current design of the SDK, they are sort of separated.
Got it. Okay.
But that's something that we're actually thinking a lot about, really on the interaction and design side about what is the interplay between your hands and the actual controllers? What does that handoff look like? Like, can you make that actually seamless? So these are all areas for exploration that I think we'll do some cool things with.
I think the hand tracking is going to be a big development, obviously, or a big new toy to play with for developers. What do you think would be some things that they should start with in terms of like early lessons? From my experience, if I am expected to grab something and I put my fingers through it, it drops the illusion. Whereas if I have a force power, or if I'm causing something to levitate, or if I'm putting up Doctor Strange magical beams in front of my hands, that works a little more convincingly.
Yeah, we've actually been thinking a lot about the design interactions. One of our team members, Jenny Spurlock, she's actually invested a lot in just what are the right gestures. Should you actually directly manipulate something, which has challenges though of you're physically moving your arm, like will your arm tire out? Is an object actually that at this arm's length distance going to be, say, legible based on the focal distance of the headset, or should it be something that's a little bit further out and say, maybe you would ray cast with your hand, sort of select something and then do gestures to manipulate. So these are actually really open questions. We haven't solved all of it, and I think we're exploring a lot, but as we release the SDK, I think we'll learn a lot about how developers use it.
And it sounds like it's the logical next step into incorporating control labs and their kind of hand tracking, their take on it using just neural signals.
Yeah, I think there's a lot you can actually do with it, and how you improve on it, how you add sort of fidelity to that system. We really think about hands, sort of for three key things. The first one is social presence. Just as we interact, having your full hands here versus, say, a controller where you're inferring a lot of your finger presence, just hands are strictly better on that. The second one is actually just self-presence. So when I enter, enter VR, today you're just kind of lost without your hands if you're not holding the controllers. And so being able to have your hands in there and then get to controllers is really nice. And the third is just really frictionless input. So as you think about a lot of use cases, especially on the enterprise side, being able to just hand a headset, whether it's to a client, to another employee, not worrying about unfastening the wrist straps, passing over Oculus Touch, and just having your hands directly in there is just a really seamless experience.
I'm curious about the social implications that you mentioned. Are the Horizon avatars being developed with hand tracking in mind?
I believe right now they're actually being done with the actual controllers in mind.
Right.
Just because as you think about content interactions, you want a lot of that precise input or haptic feedback. So for now, I think they're focused on the touch side.
Okay. I mean, it sounds like hand tracking, big investment. You guys have been thinking a long time. Rift S also out this year. Is there any technical limitation preventing Rift S from also getting hand tracking?
We focused it right now specifically on Quest. Obviously, though, at least there's really sort of two sides to this. One is on the developer side, and the other is on the consumer-facing side. On the developer side, a lot of people develop on Rift or Rift S and then bring it over to Quest. So we do expect that Rift S will have some sorts of hand tracking support on the developer side, just to test things out and ease that development cycle. But on the consumer side, I think we're really focused on Quest first and foremost, and want to see how it does on that platform before we figure out.
But it's not because it doesn't have the DSP.
Yeah, you've got actually then access to even a better, larger camera tracking volume.
Yeah. And it also sounds like it wasn't that you found the extra headroom in the DSP to enable hand tracking. You knew when you chose that Qualcomm chip that you wanted to leave room for that. Same with the camera design, right? Conrad talked about, it's the reason that there's overlap, stereo overlap on Quest, because that's going to help with hand tracking. Does that even go forward to more IK?
It's an open question right now. We did, in the early days, thinking about the camera configurations, we did know that, hey, this is a possibility for the future, especially as we thought about, Oculus Go and the media line and really having that frictionless input. This was like a core belief that one day we'd be able to deliver on this, and it's actually really amazing that we're able to do on the Quest timeframe. And you asked about in terms of the compute side, it's actually a pretty, I think of it like a magical feat of engineering, really, to get that entire hand tracking pipeline onto the DSP, onto the silver cores, and really not impact the content side on the compute. I am mind blown by what the team has done on that front.
That's definitely impressive.
Yeah.
You mentioned the cameras. You're incorporating Pass-Through Plus into the Quest now.
Yes.
But you won't be able to toggle that on and off at launch. Why is that?
We're actually just thinking about the interaction mechanisms that are best and don't conflict or collide with how content does things. So it's really just an exploration right now on what's the best user experience.
Okay, so it's not a technical problem. Okay.
Is there still any plans to surface the pass-through imagery or data geometry to developers part of SDK?
We've really focused this for now just on the first party and the safety sides with Guardian, but it's a thing in the future that maybe we'll see what makes sense. But for now, it's really just focused on safety.
The Go apps that you're bringing over to Quest.
Yeah.
I have some questions about that. Like Carmack said a while ago on Twitter that this was he'd hoped to bring some sort of Go compatibility layer. Is this full-fledged Go compatibility in the sense that it would run anything that you pass at it? It's just that some games run better than others?
Yeah, so the real tricky part here is depending on when the apps are developed on the different Go APIs, some of them are forward compatible, some of them aren't necessarily. And so you get some strange artifacts where you might get into a title and find that the floor is the wrong location. or that the input from the touchpad doesn't quite necessarily map over to the thumbstick in the most intuitive ways.
They didn't necessarily have positional tracking in mind when they made those games.
That's right.
Right.
That's exactly right. And so for this reason, we really want to go title by title and make sure that, hey, for these first apps of the Go side on the compatibility layer, that they really interacted nicely and as expected. And so we're going through right now that whole catalog and library to just bring over and make sure that they run really well.
So do some games magically have 6 degree of freedom head tracking?
Some of them will, yes.
Okay.
It really just depends on how that app was developed, whether or not they might have coded around it or made different assumptions inside of their implementation.
Okay, but that won't be surfaced anywhere in the store. You'll just have to find out, right?
Yeah,
okay.
it's still a work in progress, I would say, on the best way for those interactions to look, but we look forward to feedback.
Yeah.
I mean, John Carmack ended his talk today going through a big list of all the technical features of hardware as some you would consider, because you can't throw everything in a next generation headset. You've made lots of prototypes, and one of the things I noticed from Michael Abrash's showing of the Half Dome 2 and 3 is form factor getting more ergonomic and choosing that as a priority. Is it safe to say that is a precedent going forward of size and weight, as opposed to the biggest FOV and
It's actually a really big tension right now as we think about what the future looks like. So there's a number of considerations. The first side is we do want to get form factors to be smaller and lighter weight. We know that the ergonomic side, our ultimate goal is to get to a pair of glasses. And so there's a ton of innovation on that front that we need to make. That actually does, though, conflict with other goals as you think about, let's say, adding more sensors, pushing on mixed reality. All that actually expands your volume and your power size constraints. And really a lot of this is actually just driven by the battery size. Can I actually get my whole system to run all these sensors, run all the best content, do all the different tracking side scenarios, and be small enough right now to fit into that form factor? And so this is a really big tension that we think about. And then really it boils down to, what is this device, what is it being used for, what can it actually do, what's that content that's running on it? And so we try to really balance that whole holistic system around that content.
In terms of sensors that we don't have yet, eye tracking, face tracking, the things that they're working on for the future, which ones that you've seen prototypes of do you find most compelling personally?
They're all pretty magical, actually. And I really think it's in the combination of them on how do you deliver a greater sense of presence? How do we actually get to that long-term vision that Boz laid out about him and his father feeling like they're in the same room together? And that level of social presence is going to take a bit of magic. And it's not going to be any single sensor that will be the thing that just makes it happen. It's going to be the combination of those sensors and really using them in innovative ways, like using the inside-out tracking sensors for hand tracking. Sort of not something that a lot of people would have expected, but I think as we get all those different types of options on the headset itself, what we can do on the software side will be pretty magical.
So the shared spaces that you mentioned, where you're sharing a living space with one another, is that truly where one headset and the other headset share the exact same geometry world understanding?
That's an early sort of prototype that we're showing there.
Right.
That does tie to the idea of live maps, which is one of the long-term investments as we think about how do we actually map the world and get this sort of shared understanding. But it's really early right now in the research phase, so we have to think about on how actually it would roll out to people.
Horizon seems to be the next big social thing. I say next because there's a lot of examples of social experiments and apps that Oculus has put out, from rooms to venues to the spaces, and some of those are going away. As Horizon's being developed, is it something that is just another experiment, or is something that's going to get built upon, iterated upon? Are we going to see different avatars next year?
No, we're really excited about Horizon, and that is sort of the next big investment. It's actually the culmination of a lot of learnings that we had from Facebook Spaces and Oculus Rooms, and what people like to do, how they interact, what those different activities that people do together. And so that's all coming together within Horizon. And the real big part about that is this idea of world building. And so can I actually build out a world, have you come into this world? It can be something that maybe is just casual or just hanging out. It can be something more interactive, like an actual mini game that you have there. And so just seeing what people will do in that space, I think, is really exciting.
All right. I mean, I think that covers so many of the questions that we had. Thank you so much, Sean.
No, thank you guys. Really appreciate it.
Yeah, it's good to see you again.
Yeah, good to see you guys too.
Research has shown that users tend to focus more on the equator, the horizontal, like separating the top and bottom view in a VR environment when using a head-mounted display. This is very useful for designing better UX for VR. This type of research and findings is called establishing saliency in VR. Let's watch a video discussing saliency in VR.
Look closely at this scene. Which parts of the scene did you look at? The photographs on the shelf? The dining table? The kitchen? Here's how 49 people explored the scene in virtual reality. Users saw this scene with a head-mounted display starting from one of 4 starting points, and the data you see represents their scan paths. We can process the scan paths to compute a saliency map. This map can be interpreted as a probability distribution, modeling the likelihood that a user fixates on certain image regions. Saliency prediction for desktop viewing conditions is an active research area in visual computing and applied perception. However, virtual reality is different from desktop conditions due to the complex interaction of head and neck movement, gaze, and other kinematic constraints. But knowing where people look in these virtual environments is useful for several areas of active research. To further our understanding of viewing behavior and saliency in VR, we recorded almost 2,000 head and gaze trajectories from users exploring 22 stereoscopic scenes in 3 different viewing conditions. This dataset will be made publicly available. Detailed analysis of the dataset can be found in the paper and the supplemental material. Here we highlight the main findings and explain how we can apply them to saliency prediction. First, we find that we can apply existing saliency predictors to VR with simple modifications. One important insight is that users fixate on the equator more than they fixate on extreme angles. We can quantify this equator bias for different viewing angles using our recorded data. We improve the accuracy of existing saliency predictors by weighting the predicted saliency map with our derived equator bias. Second, we find that the user's head and gaze movement are coupled in VR. We show that the head orientation might be sufficient for predicting saliency without the need for costly eye trackers. Third, we show that we can predict time-dependent viewing behavior for the first few seconds of scene exploration. Finally, we find the distribution of salient regions impacts how viewers explore the scene. The fewer salient regions, the faster users look at a salient region, and the more concentrated their attention is. In addition to predicting saliency maps for images in VR, we can also use our method to predict saliency for videos in VR. We can automatically generate representative thumbnails for panoramas. To do this, we predict a saliency map for the panorama, and then we find the window of maximum saliency. We can also use our predicted saliency maps to automatically generate a GIF preview of a VR video. Here, an algorithm uses the saliency map to find high saliency windows with roughly continuous content. Another application of saliency maps is aligning cuts in VR videos. One way to do this is to maximize the Pearson correlation coefficient of the saliency maps of the frames immediately before and after the cut. Using this approach, the 2 frames before and after the cut are automatically shifted such that the 2 actors in the frames align. Finally, the bandwidth required by high-resolution VR images and videos is a daunting challenge for interactive or cinematic content. To reduce the bandwidth required, our saliency compression approach retains high resolution for high saliency regions, while compressing less important regions more aggressively. Saliency is important for many VR applications, yet no models exist to analyze and predict user behavior in immersive environments. With this paper, we further our understanding of saliency in VR, we present methods to predict saliency in VR, and we outline a number of applications to spur follow-up work in this emerging research area.
When we think of VR, our minds naturally gravitate towards three-dimensional environments and interactions. But there are times when it's necessary to present content in a two-dimensional way. With VR, we have an opportunity to reevaluate the nature of screens and how we view and interact with screen-based content. This talk will cover techniques the Daydream team uses to create legible, usable screen interfaces in VR. We will introduce new workflows, new units, and highlight interaction opportunities and pitfalls. Let's watch a video discussing user interaction in VR. Let's reflect on what we have learned so far.